Hey class, how are you doing today? Today, we're going to cover chapters 5. I hope that you are enjoying our class thus far. Remember, we're not testing your brain, we are testing your system. So today, what we're going to cover is discrete probability distribution. Once again, don't get bogged down in the calculations. Make sure that your system, the tool that you're using, the Excel document, the Excel template that we're going to be using is straight. And that will help you to have a system in place that can provide successful results over and over again. Are you ready? Let's go. We're going to get into this whole topic of discrete probability distribution. So what I'm going to do is I'm going to share my screen with you all. And once again, my head is going to be on a swivel because I got multiple screens. All right, so bear with me as I do so. All right, so you should be able to see my screen. And like I said, today what we're covering is discrete probability distribution. Now, if we were to break this down, you would see that this may seem complicated, but it's really not. Remember in chapters 1, we talked about discrete numerical variable? Well, it's basically using that same concept. Discrete, it is an exact, precise number. All right. So, like at exactly zero, what is the probability? At exactly five, what is the probability? So, with that concept in mind, you can understand this whole concept of discrete probability distribution. It is exact and precise, the probability at an exact, precise point. And probability is a chance, the likelihood of something actually happening. And the distribution is the data as a whole. So, can we understand the probability at a specific point when we're looking at the data as a whole in terms of probability? Let's go, let's go. Hopefully, this makes sense to you. When we're talking about probability, we're talking about a value, a decimal value, all right, a number between 0 and 1. So we're going to find out these probabilities and help us inform us on how we can actually use these probabilities to make informed decisions. Let's go, let's get into it. All right. From a high level perspective, I always want to talk about probability or these topics from a Christian worldview perspective. Now, remember, discrete probability distribution is an exact, precise point as it relates to everything that you're dealing with, the distribution of your data. So, my question then, from a high level perspective, is can we ask ourselves the question, what is the probability that you actually have fellowship with God? Is there such a way to prove that we have fellowship or not? It says we, I want you to hear it as the distribution, but I also want you to hear if I, if you, if me as an individual, how can I know if I have fellowship with God? Well, I'm glad you guys are asking. We're going to look at a scripture verse, and from that scripture verse, you can determine if you have fellowship with God. Remember when we first started this course, we started off with the whole concept of the earth being formless, empty, and dark. And the solution to formlessness, emptiness, and darkness was let there be light. So, from that same concept, we're going to talk about fellowship with God. And my scripture verse today comes from 1 John 1, 6 through 7. And it says this, if we claim we have fellowship with him and yet walk in darkness, we lie and do not live out the truth. But if we walk in the light, and then this is where my graphics come into play, boom, as he is in the light, We have fellowship with one another, and the blood of Jesus, his son, purifies us from all sin. So to break that down even more granularly, it says, if we, and can you look at yourself and say, if I claim I have fellowship with God, we collectively as a whole, but yet we're walking in darkness, we're walking where we can't see, then we are lying. But if we walk in the light, if we walk and follow what Jesus is doing, then we have fellowship with one another. So here's the breakdown. On a daily basis, how is your fellowship with someone nearby to you? Your family, your friends, your classmates, your coworkers. Do you have good fellowship with them? And if you don't, is this saying that then you're walking in darkness? Because if you're walking in the light as he is in the light, you will have fellowship with one another. All right. But here's the kicker. There's going to be problems when walking with people, right? This just in general, just know that. But the blood of Jesus, his sacrifice purifies us from all sin. Today, we're trying to show you the actual walk. How can we actually use data and information to help us understand probabilities at exact, precise points? Can we prove if something is really what that probability is at that specific point or not? So follow me as we go into this. And once again, we're going to walk through this process, and hopefully there's going to be light shed for you to be like, ah, that's how I find the probability at that specific point. Oh, that's how I find that probability over there. Today we're talking about discrete probability distribution. All right, so how are we going to break this down today? We are always going to deal with random variables, random. There's no bias, there's no subjectiveness. It is straight randomly selected. There's no rhyme or reason. Everything within your population has the opportunity to be selected. It is randomly selected. We're going to show you how to do a discrete probability, expected values, binomial, Poisson, hypergeometric. We're going to show you different probability distributions and show you how to find a probability at those specific points. All right, let's get into it. When we're dealing with probabilities, all right, we're dealing with sample data as it relates to the population data. All right. So when you see these parameters, please understand that these different parameters, whether Greek letters or whether you're dealing with non-Greek letters, regular letters, all right, we are pulling from the sample to understand the population parameters. All right, good. When we're talking about probabilities, like I said before, we're dealing with random variables. All right. If it's not random, if it's subjective, if someone came up with these ideas or how to get this sample, then it no longer follows the rules of discrete probability distribution. It must be randomly selected. All right. And then when we describe discrete probability distribution, we're going to show you guys how to describe it in terms of tables, how to organize it correctly, in terms of graphs, how to visualize it correctly, and in terms of formulas, how to calculate it correctly. So we're going to take a three-step approach basically to show you how to do these discrete probability distributions. Let's go. Let's go. All right. So the first way we're going to show you is through some rules. And we're going to use special mathematics. All right. So when we're dealing with discrete probability distribution, we're dealing with an exact probability, but we no longer say probability as P, right? Because probability is a range of values. When we're dealing with these probabilities, we're dealing with exact discrete values. So we're going to say f of x. All right. But it's the same in your mind as a probability. So hitherford thus, when you see f of x or when you see f, don't be like, what the f is that? All right. What you're seeing is the function of x. Yeah, yeah. All right. So once again, probability is always between 0 and 1. All right. So discrete probability distribution, once again, is between 0 and 1. All right, good, good, good. So here's an example. Like I said, we're going to try to organize it in a table. We're going to try to visualize it in a graph, and we're going to show you the calculations behind it. All right. So here's a good example. Let's say we're using this DiCarlo Motors. All right. Using past data on daily car sales for 300 days, a tabular representation, a table, a organized representation of the probability distribution for sales was developed. So they developed 300 days of their sales habits. All right. So we put it into a table. So just so you can get a brief understanding of this. 0 days, in those 300 days, for 54 days, they sold 0 cars. All right. On 117 days, they sold 1 car. 72 days, 2 cars, and so on and so forth. All right. And then they got the most cars that they sold in one day, all right, is 5 cars. And that happened 3 times in those 300 days. All right. So once you have the frequencies, of course, you can find the probability at each specific point. This is what we've been doing before. All right. So how do you find the probability if it's at 54 for 0? You're basically taking that 54 divided by 300, and that's how you got 0.18. Right. So those individual numbers are your probabilities at those specific points. Yeah, yeah. So once we have these probabilities, once we have our x values, then we can graph it, right? So here is our graphical representation, all right? We can use either a box plot or a scatter diagram, all right? But we have not a box plot, a bar chart, all right? But we can show that at 0, all right, it's going to be about 0.18 right here, and so on and so forth. So we can actually see what the data looks like. All right. So for the most part, they wish they can get more of these, but you can see on average, they're doing something around 1 to 3 cars per day. Yeah, yeah. More like one. Anyways. So we can represent it by a table, we can represent it by a graph, and we can represent it by calculations. All right, so now let's get into the actual calculations for discrete uniform distributions, binomial, Poisson, and hypergeometric. All right, once again, like in chapters 3, we talked to you guys about getting to the promised land. Please don't get bogged down with the formulas. The formulas are there. They've already been tested and proven. Your job is to find the most effective and efficient way of doing business, of doing these calculations. All right. So what I'm going to do is provide you the manual formula and then show you a more effective way in Excel on how to do it. All right. So here's the formula. If we want to calculate it uniformly, all right, just generally, here is the manual formulas. Yee. All right. So for your f of x, all right, you're doing 1 over n in general. All right. You got your sample size. All right. Let's say you're rolling a die. There's 1 out of 6 possibilities. All right. Then you can calculate the population's mean by using this formula. You can calculate the variance, the spreadness of the data, or the standard deviation. Please be reminded that the variance and the standard deviation are doing the same thing. Only difference is the standard deviation makes more sense to our human brain. All right, so now that you have that, how do we do this in Excel to make this a lot easier? All right. So in general, you will have your data looking just like this, just like we talked about in that example. All right. And that car, how much cars are they selling? All right. Here is the data. You will put it into a table form. All right. You will put your probabilities in there. And then you will be able to calculate your mean, which is the first one. All right. And then you'll calculate your square deviation from the mean. So the steps are, the rules are, is first, calculate the mean. Second, calculate the square deviation from the mean. All right. But watch now. The means calculation is the sum product. All right. So you're taking these two, this times this, plus this times this, plus this times this. Does that make sense? So it is the sum product of these first two columns to get you the mean. All right. The reason why we need the mean is because when you look at once you get once you get to here, or this bar right here for the variance, sorry, you will need, oh, let me stop and rewind. Here is the math calculation for the sum product. Here's that big E. It says sum up everything to the right of me, right? All of your X values and all of your F of X values. So you go boom times this plus boom times this. In Excel, it is simply just the sum product. All right. So now that you have that, now let's get into the variance. In order to calculate the variance, we first must do the sum product of this equation times f of x. All right. So this equation right here, where it says x minus the mean squared, is the square deviation from the mean. All right. So that's why the second part of our rule is to get the square deviation from the mean. Then we can do the sum product of this times this. Am I making sense? So this times this plus this times this plus this times this, and so on and so forth. So that's the second part of it. And that's how we calculate the variance. It is this section, this column, times this column, the sum product of these two, and you will get your variance. And once you have your variance, it's too easy to get your standard deviation. It is the square root of your variance. All right. So once we get into the homework, we'll give you an example or a couple examples of this so you can actually see how simplistic it is to get this data. All right. So now let's go on into binomial distribution. An easy way to describe binomial distribution is, let's say, for example, I'm a baller. Should I call it brawler? Anyways, I play basketball, right? And let's say I can cook at three-pointers. Not Stephen Curry level, all right? More like the rec level. So I would say my success rate at three-pointers, let's say it's at 30%. All right. And I'm going to use this example right here. Here are your calculations that you will need. If you want to find a probability at each specific point, this is what it looks like from a mathematical perspective. Yay! All right. We're going to show you how to do this formula in a simplistic way using Excel. So here's my Excel example down here. All right. So instead of doing all of this, all we do is equal to bino or binomial dot this distribution. All right. And then we got B5. All right. That's the zero value. And then we move over to D1. All right. D1 is that first number, your sample size. All right. We got a sample size of 3. All right. And we got a success rate of 0.3. So if I shoot the ball at 0.3, all right, 30%. 30%, I'm going to knock down those three-pointers. All right. If I had 3 shots, what is the probability that I will make 0 shots? What is the probability that I will make one? What's the probability that I'll make two? What's the probability that I'll make three? So for binomial probability distribution, once you know that success rate, you can then calculate the probabilities that you're going to make zero shots. All right. If you were to take three. All right. So now, can you see how useful this is for like NBA players or professionals? They now can actually look, all right, Stephen Curry, you shoot like at 40%, all right, or maybe even 50%. All right. How many shots do you need to take to help us win this game? All right. How can we make sure that you get those shots so that we can win this game? You see? So this is valuable. All right. So we can actually use binomial distribution. But what we're saying to you is please don't get bogged down in the actual calculations. We're going to be using the simplistic form within Excel to calculate the binomial probabilities. Yeah, yeah. All right, good. Poisson distribution. It's dealing with some kind of time or space kind of problem. So for example, the arrival times or how long does it take or whatever examples you may have that deal with time or some kind of space kind of problem. Poisson, it looks like this with the regular calculation. All right. Yeah. All right. Some of you guys like this as mathematicians, but some of you looking at this like, I don't know. But within Excel, you can break down this formula and find the probability at each specific point as such. All right. All you need is the actual mean. Once you have the mean, you can find, for example, the number of arrivals at an airport within an hour. Is there going to be zero arrivals within that hour? Is there going to be one arrival, two arrivals? You can calculate the probabilities at each specific point. All we do is Poisson that distribution. All right, we do that before. Once again, that relates to the first X value. All right, and then we got D1. All right, and that relates to the mean, wherever you have your mean. And then for if you're paying attention to both binomial and Poisson, and when we get to hypergeometric, they all end in false. The reason why it's false, it's not a range, it is an exact, precise value. All right. So with discrete probability distribution, you're going to see it ending in false. Once we get to chapter 6, you're going to start to see it ends in true because they're dealing with a range of data as opposed to an exact, precise point. All right. So with this, we can find the probability at each specific point. All we're using is Poisson, however you want to enunciate it, that distribution, and we can get our answers. All right. Last but not least, hypergeometric. This is I don't know how you say this, but a hyped up version of binomial probability. So binomial probability is more focused on like an individual. If I know my success rate, how many shots do I need to take? Hypergeometric is more like a team kind of thing. All right. Based on the collection as a whole, based on the population, your entire team, your entire conference, your entire district, state, the nation itself, you can actually compare and see based on the probability, based on success rate, if you're successful or not as it relates to everybody, not just yourself. All right. But this is what it looks like. To find the probability at that specific point, here's your formula. Yeah, good luck to you on that. But if you were to use Excel, this is what the formula looks like. Hopefully you can see that way down yonder. All right. We use hypergeometric, basically, that distribution, and we have these four parameters. It ends in false, and we can find the probability at each specific point based on you as it relates to the entire population, or based on one thing as it relates to everything. Yeah. All right. So now that we said that, we want to now go into the actual homework assignment. You guys are going to be able to calculate probability, discrete probability distributions uniformly, binomially, and Poissonially. All right, I'm making up stuff. But yes, let's get into the homework and let's see how we can actually work this and make sense of it. So if you can you go to the classroom? Let me click on this. All right. And it's either going to be in week 5 or week 6, wherever it is. Look for your chapters 5. Click on it. All right. And open the assignment. Right. While I'm opening that, in the description below this video, you will be able to see where to click on the Trello link. In the Trello link is where you can actually grab the Excel for chapters 5. So once I get loaded into here, I'm going to grab the Trello link and then I will make sure that you guys can actually download the Excel for chapters 5. All right. So here is my Trello link. Great. I have my Trello link in my class, so I'll go there. All right. And I'll download that, open that. All right, once again, the link to the Trello is in the description below. So click on it. All right, so now we are at exam 2. We're prepping and preparing for exam 2. Please save your Excel templates. All right, so what we're going to do is go down to chapters 5 through 8 Excel templates. Click on that. All right, and we're going to download chapters 5. Click it. All right, download it. All right, and open it, please. So once again, because I am on Zoom and also using PowerPoint and also using Excel, some of my features are going to be really slow. So I'll try my best not to be selecting stuff to mess it up. All right. So if you can, open up chapters 5 and let's save it. So please save it to your desktop. So I go File, Save As, Browse. For my Mac users, go to your file, go to Save As, and make sure you click on my Mac or wherever you have your BUS352 folder. So I'm going to grab mine, browse. All right, here we go. Let me find my desktop. Oh, it's right here. Let me go. Uh, all right, let me click on my desktop. Yep, go this way. I'll go to BUS352 and I'll save it right in here. All right. Perfect. Now, once you have Cengage open, once you have your Excel file opened and saved, then please do a dual screen. For my Windows users, I can just click from right here and drag it over. Perfect. And I'll also select my one for Cengage right here. All right. If you can, please start off with 5.08. Click through until you find exercise 5.08. Nope, that's not it. All right, perfect. 5.08. Once you get there, then we can actually do the calculations. All right, so this one is a good example just to kind of show you how to put it into a table. All right, how to do the calculations and how to graph it. Yeah, yeah. So these are some really good examples. All right, the following data were collected by counting the number of operating rooms in use at Tampa General Hospital over a 20-day period. All right, so we got 20 days. On 3 of the days, please enter your numbers. So on 3 of the days, only one operating room was used. So I'm going to put 3. All right. Please put in your numbers as you see them. So mine, it says on 6 of the days, two were used. Good. And then on seven of the days, three were used. And last but not least, on four of the days, all four hospitals were used. All right, good. And of course, your total should end up as 20. So then we go over here. How do you find the probabilities? It is simple. It is this number divided by 20. All right. But we have the formula right here. So double click. Please highlight from the equals to sign all the way over. Copy it. Control C, Command C, if you're a Mac user. Double click in here. Double click and paste. Control V, Command V. And do you see how it selects B2, which is this blue, divided by $B, $6, which is the red down here. All right. Now, remember, when you see dollar dollar, you should know that you can drag that formula down so you don't have to do it over and over again. Find the most effective and efficient way of doing your business. So I'm going to double click. Uh, All right. It's not going to double click. I'm going to press enter and then double click. Perfect. It drops it down, or you can drag it down, whichever one works for you. All right. So if there's going to be one operating room used, all right, it is basically 15%. All right. If there's two operating rooms that are going to be used, it's a 30% chance that it's going to actually happen. So once you have your data here, then you can plug your numbers in here. All right, so please make sure you're putting in two decimal places if need be. And remember, all of your probabilities add up to one, or if you multiply by 100, 100%. Perfect. So which graph is correct? All right, so what I'm going to do is actually graph this. I can do it like 1, 2, 3, 4. So I'm just going to select just this. And I can click on, I'm going to maximize this, zoom in on this a little. You can click on Insert and look for your bar chart. Right here. All right, that one right there. Perfect. And I'll smallify this just a tad bit so I can drag it down in here. All right, maybe a little smaller. Perfect. And that's what that looks like. All right. So we got at one, at two, at three, and at four. Typically, your probabilities could start from zero. But if there's no data at zero, then it won't start at zero. Just keep that in your thoughts. All right. So we were able to organize it by using a table. We were able to do the calculations, and we were able to graph it using a bar chart. All right. Now for these rest of these answers, it is drop down. Just get it right. Just get it right. Which one of these looks right? If I were to eyeball this, it more looks like three. All right. And this one here, I don't know. All right. But I didn't look to read into it, but that's on you. You guys look and read into it and get your answer. But as you can see, all right, what the answer is going to be. All right. But yes, make sure that you understand how to put it in an organized way, how to do the calculations, and also how to graph it. All right. So in terms of the COPAS, organize, visualize, and analyze. All right. Good, good, good. Let's go to 5.16, please. 5.16, click through and find it. Right in. All right. 5.16. All right, this is an exam question, so please make sure that you understand this concept and you have your Excel filled out correctly. So what I'm going to do is bigify this just a tad bit. All right, please enter your numbers as you see them. Don't forget, junk in equals junk out. All right. Also enter your probability values. Once again, we're putting them in a nice table format to keep it nice and organized. Perfect. So remember, step one, if we're dealing with uniformed distributions, probability distributions, is step one is to calculate the mean. Step two is to calculate the square deviation from the mean. Step three is the variance. And then step four is your standard deviation. So what we're going to do is grab this formula, copy it, double click, and paste it in there. All right, you'll see that it will automatically select both columns. It is the sum product of those two columns. When you press enter, you will have your mean, your average. All right. Step two is to grab this formula, the square deviation from the mean, grab it, copy it, double click and paste. All right, because you see dollar dollar, you know you can drag it down. So go to the bottom right of that cell and drag it down. Now you have the square deviation from the mean. So in order now to get the variance, you need this column and this column populated, which you do have. So I'm going to grab this formula, copy it, paste it. Now we have the sum product of these two columns. All right, press enter. Last but not least, the standard deviation is pretty simple. Grab this formula, copy it, paste it. All right, it is the square root of your variance. Once again, the standard deviation makes more sense to our human brain. All right, how spread apart are these numbers right here? Basically 1.7. All right, so now that we have that, we got to make sure that we're doing the right decimal places. This first one, you should set to one decimal place. So right under the numbers or the percent symbol, set it to one decimal place. Good. And these two right here are set to two decimal places. Perfect. Enter your numbers and see if you're right. Perfect. All right. So now that we have that, we can move on to 5.21. All right. It is the same concept here. So click through until you find 5.21. All right. Perfect. And what we have done is we've already put the data into the Excel file. All you need to do is step one, calculate the mean. Step two, calculate the square deviation from the mean. Step three, calculate the variance. And then step four, calculate the standard deviation. All right, so we're going to do step one real fast. We're going to grab this formula, paste it. All right, it is the sum product of these two columns. Good. We're going to do the second one right here. So we can see this guy over here. I'm going to maximize this so we can just focus in on this. And let me zoom in just a tad bit. Perfect. All right, the sum product. Copy that, paste that, and you'll see it's the sum product of these two columns right here. All right, press enter. Perfect. Now for this one right here, here is your formula. Grab it, copy it, and paste it. All right. Now you can see that we're going to be using this formula over and over and over again. So in your mind's eye, you should be thinking dollar dollar somewhere. All right. So if you double click on X, it highlights X and you can click on this X value right here. Click it. All right. The mean, if you double click on the mean, you can click your means value right here. Click it. This is what we're going to make static. All right. Because the mean always is the mean. The X changes, but the mean remains the mean. So we're going to do $ in front of the B, $ right after the B. Once you have that, you can drag it down. Bam. All right. We'll do the same formula for this one over here. You can copy this, highlight, copy it, paste it. All right. Double click on your X, grab your X value, double click on your mean, grab your means value, and we're going to make D5 static. Dollar, dollar. Then we can drag it down. So hopefully you're getting the same concept over and over again. That first, we're going to calculate the mean. Second, we're going to calculate the square deviation from the mean. Third, we're going to calculate our variance. Copy that, paste that. These two columns. We'll do it for middle managers as well. These two columns. All right, once we have that, we can calculate our standard deviation. Right? And you guys can get this last answer right here. So I'm going to slide this over. All right. And you guys can enter your numbers as you see them. All right, check your work. Once again, we all have the same numbers on this one. If it's not orangified for the most part, it means that we all share the same thing. We want you guys to work together. So if you have a classmate, please work in tandem with them and get it right. Get that A. All right. So let's move on to this one. All right. And then on this one here, once again, read the question and get it right. All right. So just check my work. Outstanding. All right. So with that said, let's move on to 5.32, please. 5.32. This, I believe, is an exam question. So let's make sure that we get this one right. 5.32. Yes, it is. All right. Please, they're going to give you your sample size, plug it in. They're going to give you your success rate. All right. And for this X, we're going to just leave it blank. But if you wanted to find at any specific value what that probability is, you will put it in right here, and your answer will show up on the very bottom down here. All right. So know that to self. But once we have this, all right, it says consider a binomial experiment. All right. When we're thinking binomial, we're thinking, what is the probability at 0? What is the probability at 1? And all of your probabilities are going to show up in this yellow box right here. Yeah, yeah. So how does this actually work? Give me a second here. Let me make sure. All right. All right, good. We're going to grab this, copy it, and paste it right below. Now, in there, you should see dollar dollar. All right. So you can either double click or you can drag it down. For me, double clicking is much faster. So I like to double click. Now, if you look at this data, you're going to see at 15, it's going to say hashtag num blah. All right. It makes no sense. What's going on right here? What this means is that there's no sample size at this point. You see how up here your sample size ended at 14? Let me maximize this so you guys can see this a little better. All right, your sample size ended at 14. So at 15, there shouldn't be any probability, if that makes any sense. All right. So if on the exam you show up and let's say you had um, something like 20. At 21, it's going to say that hashtag num blah, all right, because there's nothing that exists there. So please, on this one, you have to keep your head on a swivel and understand what is actually happening. All right, so let me explain this first one. It says, what is the function at 0? In other words, in your mind's eye, I want you to think of it this way. What is the probability at exactly 0? You see this number up here? That will be your answer. So for example, I'm going to grab this formula, paste it. It is that. It's equal to F2. This value right here, if I press enter, all right, they give me 4 decimal places. Let me see how much Cengage wants. 4 decimal places for all of these, and then 122. All right, good, good, good. All right. So on that first one, let's see if we are right. Slide this back over here. Perfect. All right. On the exam, this is going to change. All right. So this is why we put question marks in there. They can give you what is the function or what is the probability at 6. They can give you the probability at 20 or 30 or whatever number they decide to give you. On the exam, your head needs to be on a swivel. What number did they provide you? 6. All right. So I'm going to say, I'm going to change mine to 6. All right. So this is going to be equals to, I'm going to grab this formula, paste it over here, double click on these question marks. What is the probability at exactly 6? You hover over it and click it. Click it. That will be your probability at exactly 6. For my case, what does yours say? Do equals to and click that number to the right of the number that they're talking about. Yeah, yeah. So in my case, it is, uh, check my work. Perfect. Then it goes on to say, what is the probability that it is less than or equal to 4? All right. So in my case, once again, these are templates. So you just got to adjust them accordingly. I'm going to get rid of this question mark and put 4. It is the sum. So I'm going to grab this formula, copy, paste. Please double click on these question marks right here. What it is, it says, what is the probability of X, which is less than or equal to 4? So in your mind's eye, I want you to take your mouse and hover over 4, click on 4, and drag up. Why? Because it's equal to 4 and less than 4. So you must do the sum of all of those probabilities. All right. So in that case, I'm going to press enter. The sum of all 4 of those. Check your work. Make sure you're good. Yes, indeed. All right. Now, this next one is quite interesting. It's similar, but now is what is the probability of X greater than or equal to 1? All right, good. So I'm going to go in here, change mine to 1. I'm going to grab this formula, double click paste, double click on the sum. All right. You must start from that number that they provide you, 1 or greater. You go all the way down. Please do not include this hashtag num blah. It doesn't exist. Stop at your very last sample size. In my case, my last sample size is 14. So I'm going to do the sum of all of these. Press enter. All right. And I will enter my number in there. Check my work. Yes, indeed. All right. And then for these, it is just these simple calculations right here. So just copy the formula, paste. Great. You can actually see where it's tagging to see how it actually did the calculation. All right. And then last but not least, my standard deviation. All right. We can enter these numbers and you guys should be good to go. Check your work. Outstanding. So this is an exam question. Please make sure that everything is set up correctly. All right. So now that we have that, please let's move on to 5.33. So click through until you find it. Perfect. Same kind of concept. What is your sample size? In my case, once again, this is a binomial experiment. All right, so you got 30 sample sizes. All right, your success rate is 70%. Okay, not bad, not bad. When I press enter, these numbers should populate. Yep. All right, both of these populate. So you can actually double click on this one, double click on this one. All right, you have your numbers, you have your square deviation from the mean. Let's go to work. All right, so here you can use this formula, or if you understand the concept, you could have just did equals to what is the probability at 12? Click it. Yeah, yeah. So in my case, it will be that. And once again, we all have the same answers for these. Point to zero. Let me make sure. That's a sample of 20. So please make sure you type in the numbers correctly. Perfect. Outstanding. So here's the same concept. You can use this formula or you can say equals to. We already did all the calculations. What is the probability at 16? Click it. Mhm. Then we go on to what is the probability of it? Let me put in my number for 16. Perfect. What is the probability of x greater than or equal to 16? So I'm going to grab this sum. I'm going to do this guy. Copy, paste. All right. So when it says greater than 16, so you start from 16 and go where it ends, all the way down to the last value. Yeah, yeah. Press enter. All right. Good. Check my work, make sure this is good. Mhm. All right, then it goes on to say what is the probability less than or equal to 15? Same concept, copy the formula, 15 and less. Drag up, click and drag up. All right, press enter. Hopefully you're starting to see, yes, it looks complicated, but it's pretty simple once you know what you're doing. All right, good. All right. So once you have those values, you have your probabilities, you have your square deviation from the mean. Now you can calculate your mean. Here's the sum product. But you have your x and you have your probabilities. And that's how you get these two columns right here. That's the mean. All right, we went ahead and got the square deviation from the mean a little early, but that's okay. All right, we're gonna grab this, copy, paste, copy and paste. All right, so type in your numbers, make sure that you're good on all of these. Check your work. Outstanding. Good work, good work, good work. All right, so let's go on to 5.35, please. All right, where did I see that? Yeah, don't remember. All right, perfect. All right, so once again, here's another binomial probability distribution. All right, the Center for Medicare and Medical Services reported that there were 2,000 or 295,000 appeals for hospitalizations and other Part A Medicare service. For this group, 40% of first round appeals were successful. So that is your success rate. If you're going to appeal with all of the sample size, yee, all right, 40% were successful. Suppose 10 first round appeals have just been received. So your sample size in this example, that population is that 295,000, but we're talking about just 10. All right, 10 success, 10 10 first round appeals at a success rate of zero point 0.4. We got to change that percentage into a decimal value. All right. So once we have that, you can see that this is populated. If you were to double click on this, these are the probabilities. You will see that it is dollar dollar. So that way, you know you can drag this down. So I'm going to double click on it to let it fall down. All right. So now that we have this, we can find the probabilities. It goes on to say, compute the probability that none of the appeals will be successful. We already know that 40% will be successful. What happens if we want to find out if none will be successful? What is the probability? Here, it is simply equals to, click it. Hopefully that makes sense to you. All right. At f of 0, in other words, it is this number right here. This is your probability. All right. So less than a percent. All right. Check your work. All right. Compute, compute the probability that exactly one of the appeals will be successful. Same concept. You put equals to at exactly one. Right? So now it's time to go up. You're talking 4%. Yeah, yeah. And on these, they want four decimal places. All right. Good work, good work. What's the probability that at least two, when you hear at least two, all right, for many people, when they hear at least, it all depends on your cultural background. For me, Um, my culture, all right, the way I understood it when I heard at least, I thought it was two or less. All right. But in business statistics, when they say at least, it means two or greater. All right. So this is why we're doing the sum of, grab this formula, copy it, paste it. It is the sum of, ah, make sure that you're selecting two or greater and not all of it. All right, so it should be E4 to E12. Make sure you're doing it right. All right, that's one of the gotchas in there. So if I were you, I would change this to E4. Yeah, yeah. All right, plug your number in. Check your work, make sure it's good. All right, we may update this Excel before you guys get it, but if not, just make sure that you're using the right calculations. Good. Now, what's the probability that more than half? All right, so here's your formula. More than half. Does more than half include 5? Hopefully you're saying no. All right, so it's 6 and greater. You can press enter and plug your answer in. Check your work. Make sure you are good. Perfect. All right. Two more to go. Let's go. Let's go. Let's go to 5.44, please. 5.44. Perfect. This one, we're dealing with Poisson distribution. That was the first one. All right. When you show up to the exam, you're going to have a similar problem like this, right? With this, you say consider a Poisson distribution with the mean, the population mean of 3. So we will plug that number in, right? Plug in your number, please. Good. So then, if it's 3, which one of these formulas is correct as it relates to this formula right here? So what I'm going to do is bigify this so you guys can actually see this. Here is the formula, right? If I were to replace that mu, that u, with 3, which formula would be correct? So if I'm eyeballing this, it more looks like this one C in my case. All right. So please make sure that once you get to the exam, you understand for parts A, all right, section A, what your answer is based on your mean. All right. So please make sure you get that right. So in my case, it will be C. All right. Then it goes on to say, what is the probability at exactly 2? All right, so I'm going to copy that. I'm going to paste that exactly 2. Great. What is the probability at exactly 1? You can put equals to and click it. Great. What's the probability of greater than or equals to 2? So copy this, paste this, 2 or greater. All right, that looks right. Good. So good type into you. Me, I just copy these and paste them to go a little faster. Right. Right. Once I copy and paste, now I can check my work. Outstanding. All right, we got one more to go. Let's do this. So don't forget that one is a exam question. So please, if you would, let's go to 5.49. All right. So in here, you're just basically looking at a Poisson distribution again. But what we're looking for is what is the mean? The mean arrival time is 10 passengers per minute. All right, good. So once we press enter, this should populate. Great. I'm going to double click or drag it down. Bam. All right. The first question is computer probability that no arrivals in 1 minute, in a 1 minute period. So this will be equals to, and you see E2, click it. Yeah, yeah. All right. 3 or fewer. Grab this formula right here, copy it, paste it. 3 or less. Yeah, yeah. Press enter. Let's plug these numbers in and let's see if we can get these right. All right, on this first one, they want 6 decimal places. Yay. So I'm going to copy that. I'm going to paste that and I'm going to check my work. Perfect. I'm going to grab this one, copy it, paste it, check my work. All right, so far so good. Then it says computer probability that no arrivals in a 15-second period. All right, so up here we were always dealing with minutes, all right, per minute. Now we're dealing with seconds. So this is why over here is where we have our seconds documented. So I'm just going to grab this formula right here, copy and paste. All right, I'm going to double click on seconds. And I'm gonna type in 15. Yeah. All right. I gotta get rid of all of this. Let me get rid of all of it. Type in 15 divided by 60. All right. Good. And then for my mean, for my new mean, I'm gonna copy this, gonna paste this, gonna select my mean. All right. So it should just be B1 divided by 4. All right. Because 0.25 is a quarter of the mean. All right. So here's my new mean. All right, and then I could go to C. Here's my formula. I'm going to copy that. I'm going to paste that. All right. We ratified this formula because there, once again, is a problem. Never trust these templates until you actually put it through the rigor and see that it is right. All right. Right here, you see G1 and H1 is pointing up here. We don't need these. We don't need the labels. We need the numbers. So you can go anywhere to that blue or purple line and drag it down. You can go anywhere on that red line and drag it down. All right, now it is correct. G2H2 and it ends in false. You press enter. This should be your number. I'm going to copy this. I'm going to paste that. Check my work. All right, perfect. So if I were you, all right, just because of my OCD, I'm going to change this to H2. And I'm going to change this to G2. All right, please make sure you got the right numbers in there. You can unratify it because now it's correct. All right, but I'm not going to mess with it because my Excel is probably going to scream. All right, so I'm going to copy this last formula, paste it over here, press enter, and I'm going to grab this and let's see if we are right. Yes, indeed. All right. So there you have it. With discrete probability distributions, we can find a probability at each specific point, at no arrivals, at 10 arrivals, at 5 shots, at 0 shots. We can find a probability at each specific point as it relates to the chance, the likelihood of something happening when we compare it to the distribution as a whole. I hope this made sense to you. Use discrete probability distributions wherever you go. Have a great day. Thanks for hanging.